Hello viewers, in today's class we are going to discuss yet another important problem from definite integrals, right? So here we have the integral from 0 to pi by 4, and we have dx over cos cube x and square root of 2 sine 2x, right? So let us solve this definite integral, and here we have to make use of some important results from trigonometry, right? So let us call this integral as I, right? Now we can write this integral as cos cube x, and here we have sine 2x, right? And we know that sine 2x is equal to 2 sine x cos x, right? So this is an important identity from trigonometry, right? So if we substitute the value of sine 2x over here, we get 2 times 2 sine x cos x, right? Now we can write it as 0 to pi by 4 dx, and c, here we have 2 times 2 4, and square root of 4 is 2, so we can take this 2 outside the integral, right? And here we have cos cube x, and here we have square root of sine x cos x, right? Okay, so now viewers, at this step now we have to make use of one important step, or we can say that we have to analyze this term, right? Here we have sine x cos x. So what we will do, will multiply and divide this term with cosine of x, right? So what we will write, we'll write 0 to pi by 4. Here we have dx, then we have cos cube x, and c, in the square root term, what we will do, will divide this term, that is sine x cos x, by cos x, and multiply it by cos x. So here we can write cos square x, right? And here we have sine x, right? Because cos x and cos x get cancelled, and again we'll get this same term, right? So this is an important step which is to be implemented over here by dividing this term by cos x and multiplying it with cos x, right? Now we have half, and here this term, that is cos square x, now it comes out of the square root sign, so we have dx, and here we have cos raised to 4x, right? Because one term, that is 1 cos x, comes out of this square root sign, and that term will get multiplied with cos cube x, so we'll have cos 4x, and here we have square root of sine x over cos x, which is 10x, right? Now what we will do, we'll write half, then we have 0 to pi by 4, and c, 1 over cos raised to 4x is sec 4x, so here we'll have sec 4x dx, and here we have square root of 10x, right? Okay, now we can further write it as 0 to pi by 4, and sec raised to 4x can also be written as sec square x times sec square x, right? Because in the next step we are going to use the substitution method, and we'll put t is equal to 10x, right? So here we have now this integral. Now sec square x, 1 sec square x can be replaced by 1 plus 10 square x, that is sec square x. So here we can write half 0 to pi by 4, and here we can write 1 plus 10 square x for this sec square x, and we'll keep this sec square x as such, right? Okay, and now here we have square root of 10x, right? Okay, at this point we'll make the substitution, that is t is equal to say 10x, right? So t is equal to 10x, so therefore dt is equal to sec square x dx, and here x varies from 0 to pi by 4. So whenever x is 0, then the value of t is tan 0, that is tan 0 is 0, right? And when x is pi by 4, then we have t is equal to tan pi by 4, that is equal to 1, right? So viewers, always remember whenever we use substitution method in definite integrals, we change the limits accordingly, right? Okay, so now this integral, it reduces to half, and we have 0 to pi by 4. So now we have 0 to 1, right? 0 to 1, 1 plus 10 square x, so we have 1 plus t square, and for sec square x dx we can write dt, and here we have square root of t, right? Okay, so now we have half 0 to 1, and we can write it as 1 over t raised to half, because square root of t can be written as t raised to half, and we'll write this square root of t under 1 and t square, right? So we have t square over t raised to half, and here we have dt, right? So we have half 0 to 1. Now here we can take t raised to minus half plus, and here we have we can subtract these two powers, so we have 2 minus half, that is 4 minus 1, that is 3 by 2. So here we have 3 over 2, and here we have dt, right? Now we can integrate these two terms by making use of the result, that is x raised to n, which is x raised to n plus 1 over n plus 1 whenever n is not equal to minus 1, right? So the integral of t raised to minus half is t raised to half over half, and here we have, so t raised to 5 over 2 divided by 5 over 2, and the limits of integrations are from 0 to 1, right? Okay, now we can simply substitute the limits, and we'll take the difference. So now the value of I can be given as half, and here we have 2 times square root of t, and this is 2 over 5 t raised to 5 by 2, 0 to 1, and now if we take t is equal to 1, so we have 2 times square root of 1, and here we have 2 by 5 times 1 raised to 5 over 2, and when we take t is equal to 0, then this term and this term will become 0, right? So here we have this expression, right? Now we have half, and the square root of 1 is 1, so we have 2, and here we have 2 over 5, and this is half, and 5 2s are 10 plus 2, 12 over 5, right? And this is 2 times 6, and we have 6 over 5, right? So viewers, the value of this integral is equal to 6 over 5, right?